People probably struggle to visualize a little bit when you say like data center in space. Like we're not going to slap engines on a building and fly it up there. Like these actually look like pretty different. And so kind of walk through how you take something that's in a giant building on the ground and turn it into something that's functional in space.
A lot of people don't actually know what the inside of a data center even looks like, right?
Yeah.
And
it's some like mythical place where the internet's in the cloud or something.
Yeah, some people envision wires, some people envision boxes, but like effectively it comes down to a set number of chips and the things that we need to launch into space are actually quite small when we look at it. The more challenging part is figuring out how do you get the power for it, and that's where a lot of what we've worked on for existing like Starlink technology, the solar arrays, are what we want to utilize that expertise to be able to build a satellite that can actually launch the critical components of the data center into space itself. We like to look at this and say like, what is the actual engineering problem here? And it's really a combination of delivering power and then taking the waste heat and energy away and sending it into the vacuum of space, as you mentioned.
Now the AI satellite is actually much simpler than a Starlink satellite. A Starlink satellite has gigantic phased array antennas. It's got parabolic antennas. It's got a lot of laser links. It's much more complicated than an AI satellite. An AI satellite is essentially a lot of solar cells, a radiator, and you still need some laser links, but you don't have all of the super complex antennas that you have on a Starlink satellite. So, I mean, given the two, the easier one to design for is the AI satellite.
I was like, so this is our AI one, if you guys want to walk us through.
So the first thing that we're really looking at here is like, first you've got to make something compelling, right? And we thought that the right place to start is around the 150 kilowatt like peak power level. But as we look at the workloads with our experience with XAI, we get to actually see that we can also support about 120 kilowatts of average compute.
What we're showing here is kind of a draft version of version 1 of the SpaceX AI satellite.